Hi guys, this is May 2015 C1 question number 8. Part A. Let's start. Part A wants us to completely factorize this expression 9x minus 4x cubed. Now we can see that x is common. That's the first thing that is common between the two terms. So we can write it like this. And then apparently it seems that okay, there is nothing more common between these two. But one more thing that one should always check is the fact that is this expression of the form a squared minus b squared, which is equal to a plus b into a minus b. You see that this is if this expression is of this form, it can further be factorized into two terms, right? So let's check, and you can see that this indeed is of this form because 9 can be written as 3 squared and 4x squared can be written as 2x whole squared. So what I'm trying to say is this: the 9 can be written as 3 squared, that is 9, minus 4x squared can be written as 2x squared. So this is a squared, this is b squared from this. So from this relationship, we can write this thing as you have 3 plus 2x, that is a plus b into 3 minus 2x. Now this is the complete factorization of this. So you see that this has these three factors. So that was part A. Now in part B, the question asks us to sketch the curve C with the equation y equals 9x minus 4x cubed. Now note that this is the same equation as in part A, and you have to sketch a curve. And it also says that show on your sketch the coordinates at which the curve meets the x-axis. Now um, there are a few ways of going around this one. Now for this, when they say to show you on your sketch the coordinates at which the curve meets the x-axis, so let's get those first. So what happens when a curve is touching the x-axis? We know that y is equal to 0, right? So let's just put it like this. So 0 equals 9x minus 4x cubed. Now you already have factorized this, so that will help us, which is here. So we'll write it as x into 3 plus 2x into 3 minus 2x equals 0. Now from here you have, this is a multiplication of three terms and they are equal to 0, so then each term has to be 0 for this answer, or these term can be 0 for this answer to be equal to 0. So that means you can have x equals to 0 as 1, then you will have 3 plus 2x equals 0, then you will have 3 minus 2x equals 0. So then the answer that you'll get is x equals 0 already from here. This will give you 2x equals minus 3, so x equals minus 3 by 2, and this will give you 3 equals 2x, so x equals 3 over 2. So these are the 3 points on the x-axis where our curve will touch. So let's just mark those 3 points here. If this was our x-axis and this was our y-axis, then we can mark these 3 points. So you have x equals to 0, then you have x equals minus 3 over 2, which is minus 1.5, and this is 3 over 2, which is 1.5. Now we know that our curve will touch the coordinate, the x-axis at 3 points. And anyways, by looking at the power of x in the original expression, you can guess that. So whatever the power of x, normally those are the number of roots, and it could be that it the curve can touch x-axis on these three distinct points, which is the case in this case in our question. But it could also be that the curve is just touching, so some of the roots are repeating. In that case, the curve would not touch at uh, would not cross at three different points, but rather it will touch and just move up. Anyways, that's a different discussion. So in this case, what we have found so far, we found the roots and we found these three values and we marked those three values. Now the curve would be something like coming, touching, going up, then turning, touching, going up. But it could be, there are two possibilities. It could be either like this, so coming from down, going up, down and up again, or it could be coming from upside, down, up, down, and so on. So how do we determine that? Now in order to do so, what we can see is A simple check would be, we have the original expression with us, y equals 9x minus 4x cubed, and we know that this is one of the roots, right? X equals minus 3.5. So we can put a number less than minus 3.5 and see whether we get a positive or a negative answer. So that would mean, let's assume I put minus 4.5, or sorry, minus 4 divided by 2. So this is minus 3 over 2. Another number to the left hand side would be minus 4 over 2, which is actually minus 2, for example. So if I put minus 2 in this expression, so minus 2 is there is no hard and fast rule what number you will pick. Pick any number that is less than the minimum root that you are finding. So in this case, I have minus 1.5. I'll take minus 2. I put minus 2 in this expression and then see whether I get a positive answer or negative answer, because that will tell me that on the left hand side of this region, whether my curve is above the x-axis or the below the x-axis. That will immediately tell me which direction I'll come from. So let's just try that here. So let's say I'm putting x equals minus 2. So what I get is 9 times minus 2 minus 4 times minus 2 cubed, right? I just put minus 2 in this expression, which is the same as this equation basically. So what I'll get is y, because this was y equals. So 9 times minus 2 is minus 18, and minus 2 cubed is minus 8, because minus also gets cubed. So you'll get minus 4 into minus 8. So you have minus 18, and minus into minus is plus, so 8 fours are 32. 32. So you see 32 is greater than minus 18, so you get a positive answer. That immediately tells us that on the left hand side from this point the curve is above. So then we are able to establish where the curve is coming from, where it will go. So what we do is we start from here, because that was the only thing that was missing, right? Start from here, we turn somewhere in between, then you turn somewhere in between again, and we just keep going. So this is our sketch. Again, this is just a sketch, so you don't have to be super accurate, but this is just trying to tell the examiner that you had the logic to work out that yes, there were three roots. So 3 points, the curve is just three distinct points at which the curve touches the x-axis, and then there are two turning points, because the curve has to touch these points. So it will turn two in two places. So then all that was needed was whether it's coming from up or is it coming from below. And the way we worked out is, you took the smallest of the roots, which is minus 3 by 2 in this case, the smallest of these three roots, and then we took a number which is less than that. So let's say in this case it was minus 2. We put it in this expression, computed the answer, and it was a positive value. So that immediately told us that it is coming from above, because y is positive. In this region y is negative, in this region y is positive. So that's how the curve was sketched. So now let's move on to the next part, and I'm just gonna clean up the board. So continuing with part C has the fact that the points A and B lie on the curve C. So C was this curve that we just drew, and have x coordinates of minus 2 and minus 1. So basically at minus 2 on this curve there is a point A, and at 1 on this curve there is a point B. So, and they have given us the x coordinates, so minus 2 and minus 1. So the reason, so we can roughly calculate where minus 2 is, because this is minus 1.5, so minus 2 is going to be further on the left. So we just roughly say this is minus 2, and then 1 is less than 1.5, so between 0 and 1.5, so somewhere here. Now what we need to find is, we have to show that the length of AB, so AB, let's say, is the line, the distance between these 2 points, straight distance, is of this form, k root 10, where k is the constant to be found. So in other words, they want us to find the length AB. Now for length, we know that distance formula, AB is equal to under root x2 minus x1 squared plus y2 minus, oh, sorry, y2 minus y1 squared, where A is x1 y1 and B is x2 y2. Now what I'm writing here is basically the x and y coordinates of A are x1 y1, and those of B are x2 y2. Now we already know x1 and x2, which is -2 and -1. We need to work out y1 and y2 and then put them in this formula to get the distance. Now, how do we get y1 and y2? Because these points lie on this curve C, if you put a value of x, we'll get a value of y, right? So for y1, I'll put x1. So it will be 9 times x1 minus 4 x1 cubed. In other words, I'll put 9 times, so x1 I'll put minus 2 minus 4 times minus 2 cubed, which is minus 18 plus 32, because I'm working from the previous example, which ironically we also took the x value as minus 2 when we were checking where the curve is coming from. So this should give us 2 and 12, that's 14. So plus 14. So we have y1 as 14. Similarly, y2 can be written as for the place of x, we can put 1 because x2 is 1. 9 times 1 minus 4 times 1 cubed. So that's 9 minus 4, and that should be 5. So y2 is 5. So now we have our coordinates, so let's just put them here. x1 was minus 2 and y1 was 14, x2 was 1 and y2 was 5. So what we can put in this formula is this. So we'll have x2 minus x1, so I'll have 1 minus 2 squared plus y2 minus y1. So you have 5 minus 14 squared. So that will give you under root, minus and minus is plus, so 1 plus 2 is 3, so that's 3 squared, plus 5 minus 14 is 9, so minus 9, so minus 9 squared, minus 9 squared. This is further can be written as 3 squared is 9 and minus 9 squared is 81. So that is under root 90. Now remember there is a factor of 10 here, right? So we can write it as 9 times 10. So under root 9 times 10, and we can split this under root as root 9 times root 10, and root 9 is 3. So you get 3 root 10. Therefore, comparing k root 10 with 3 root 10, we can confidently say that k is equal to 3. So this was it. So this was question number 8 done. So hope you liked it. Let's move on to question number 9. Thanks a lot.